Okay, this is a review for Chapter 4 in APSTAT. Okay, definitely want to know those words. I just put a few that students often get confused on. You definitely know what a SRS is. Hopefully this is an easy first question. A simple random sample of size n is defined to be, let's see, so a sample chosen in such a way that every unit of the population has the same chance. It doesn't sound too terrible. Sample chosen in such a way that every unit of the population has no non-zero chance of being selected. I don't think that's it. Every set of n units, ooh, I really like the way that's written. The population has an equal chance of being selected. That seems to be it. A sample chosen in such a way that each selection is made of independent of every other selection, not quite. And a sample that is always selected with replacement. So this is the definition. Every group of size n has an equal chance to be selected. I think some of those are very tempting, so you do have to be careful. You get all parts of that in there, but you definitely want to just know simple random sample definition. Very popular question. Number 2, a material engineer wishes to compare durability of 2 different types of paving material. She has 40 different 1-mile stretches of interstate highway that she has been authorized to repave for the study. She decides to carry out a matched pairs experiment. Which of the following is the best way for her to carry out her randomization for this study? So she's going to do matched pairs with a highway, right? So I use a table of random digits to divide the 40 roadways into 20 pairs. But it doesn't look like we're putting them in a similar group, so I don't think we're going to do that because we want to pair them up so they're very similar. Divide the 40 into 20 pairs, making the roadways within each pair as different as possible. That's clearly not what we're trying to do. We're trying to make them similar. Use a table of random digits to divide the 40 roadways into 2 groups of 20, and then use the table a second time to decide which pavement to use on each group. It's at least tempting. I'm not going to wait on that one. Let each of the 40 roadways act as its own pair. Ooh, that's always good when you can do that, if it's possible. Dividing each roadway into the first half mile and second half mile. Flip a coin for each of the 40 roadways and decide which half mile gets pavement. So I like that one a lot so far. Each of 40 as its own pair. Okay, same thing. Dividing each roadway into the first half mile and second half miles. Flip a coin once to decide which pavement is put on the first half mile of all roadways. I liked up until then. So that's just flipping the coin once. Within each, what's supposed to happen with matched pairs, within each similar pair, you're supposed to do a random sample, right? So SRS inside each pair. So that's doing one simple random sample for the whole set of them. That's definitely not it. And this was close, but just not quite there. So it's got to be D. To assess the effects of exercise on reducing cholesterol, a researcher took a random sample of 50 people from a local gym who exercised regularly over the past year, and another random sample of 50 people from the surrounding community who did not exercise regularly during the year. They all reported to a clinic to have their cholesterol measured. The subjects were unaware of the purpose of the study, and the technician measured the cholesterol was not aware whether the subjects exercised regularly. Which of the following best describes the inferences the researcher can make on this based on his results? Let's see how we chose these folks again. So we took a random sample of 50 people from the local gym, took a random sample of 50 people from the surrounding community. So 2 random selections of 2 separate groups, but you're not, so they're not really doing it. There's not really any treatment here, right? So that they're doing, they're just measuring their cholesterol, I guess. We can make inferences about cause and effect. So this is not an experiment. We can't even go there. But the population, so, but not about cause and effect. So maybe that one. So B actually looks really tempting, I think, when you look at it. But I need to read all of them. I always read all of them. You can make inferences about both cause and effect. No, you definitely can't do that. About cause and effect, no. It's not even an experiment. This is not enough information to make judgments about the scope of inference. We do have random selection, so I think we can do that. So B would be the correct answer. Researchers wish to determine if a new experimental medication will reduce the symptoms of allergy sufferers without the side effects of drowsiness. Oh, be great. To investigate the question, the researchers randomly assign 100 volunteers who suffer from allergies to two groups. They give the new medication to the subjects in one group and existing medication to subjects in the other group. 44% of those in the treatment group and 28% of those in the control group reported a significant reduction in their allergy symptoms without any drowsiness. The experimental units are, they give the new medication to the subjects in one group, existing medication in the other. Okay, so we found that. The experimental unit. So the question is experimental unit. So that's the people or animals or things that are being experimented on. In this case, it looks like they had 100 volunteers. So it's got to be that one. The silly answer is researchers. These are the, we took a sample, but that's no, none of those other ones are good. It's got to be B. Pretty straightforward there. Okay, the manager at this restaurant chain wants to test the market for a new menu item, a grilled chicken sandwich with chipotle salsa. Sounds good. They're interested in both how to market this item and the right price to charge. Always a tough thing. She decides to offer the sandwich at 60 different restaurants in the chain using 2 different descriptions of the menu. Half the restaurants' menus will emphasize healthy eating, and half will emphasize value. These 2 groups of restaurants will further be divided into 3 subgroups, each charging a high, medium, or low price for the sandwich. After a month, they will measure what proportion of customers ordered the sandwich. You're trying to market this thing, figure out the right price. Suppose the manager conducts a completely randomized design, okay? Lists the experimental units, the factors, and the treatments. So I like the order of that. Let's start with the experimental units. We just talked about those are the people or the things we're working on. In this case, it's not really people. It looks like the experimental units would be the 60 different restaurants in the chain. Okay, so the factors. Okay, so the treatments are, what they're doing to them. So the factors are, what are the 2 things they're looking at? So they're looking at changing up the menus. So the factors would be the menus and let's see, the price, right? I think we're adjusting the price. So the menus and the price. So the treatments are the subgroups of both of those. So if you want to really just talk about the treatments, we could actually break it down into, you could start writing it like, so that one of the factors was a menu, like the healthy eating or the value, right? So healthy was one of them. So healthy and then the high price, we're going to say. Healthy and then the low price. Healthy and then the medium price. I think there were 3. And then the value and the high price, the value and the low price and the value. Sorry, I'm being really sloppy here in the medium price. All the 3 prices, and you got it. Just list out the treatments, all the possibilities. There were 6 different options there. Principal reason for use of random assignment in designing experiments. So random assignment of treatment groups. I thought at first it might say something about causation, right? Because that could prove causation. But when you think about random assignment, I want you to think roughly equivalent groups. So when you think random assignment, I want you to think in roughly equivalent groups. We want something to compare, right? So creates approximately equal groups for comparison. So D would be right. It's the closest thing to roughly equivalent groups, which is what I want you to, your mantra I want you to know for random assignment. Local tax group polls the residents of the school district and asks the question, do you think the school board should stop spending taxpayers' money on non-essential arts programs in elementary schools? Boy, it wasn't worded great. so they started it. I mean, the wording's kind of like, should we stop spending taxpayers' money? I don't like the wording of that. And then non-essential art programs. I just don't. I feel like it's biased in the way they're saying it. So, do you think? Okay, so what is this poll going to do here? So it's going to, so I don't think it's going to overestimate support. They're trying to convince you, the person who's asking the question is trying to not support this bill, right? So my guess is they're going to persuade some folks, and so it's going to be some kind of underestimate. Because of undercoverages, people you can't, aren't easy to get to, or they don't respond like that. I mean, you can't include everyone in the region, kind of homeless or whoever it is that's undercovered. Because of the way the question is worded, oh man, that's definitely it, right? So that question is worded terribly, so it's got to be B. And accurate, that's definitely not accurate. Okay, so E is gone. In comparative trials in medicine, the placebo effect and subconscious bias on the part of the physicians evaluating treatment outcomes can be avoided by using the double-blind technique. That's almost the definition, right? We want the subject to not know if they're getting the drug or not. So it's called the placebo effect they're going to have. And the researcher is motivated by making this thing successful, maybe some money if it's successful, or he's going to become rich. So we don't want him to know which group. We want him to treat all groups the same. And so there's some kind of like human nature to try to, make it successful, and you would try to kind of make one group work if you knew which group it was. But if you don't, you can't really do that. Okay, here's a link between vitamin E and heart bypass surgery. So evidently, large doses of vitamin E can reduce harmful side effects of bypass surgery in heart patients. A study involving 28 bypass patients found that 14 randomly assigned patients who took vitamin E, so they took a treatment for 2 weeks before the operation, had significantly better heart function than the procedure than the 14 randomly assigned patients who took placebos. So there was random assignment, roughly equivalent groups. The vitamins apparently prevent damage to the heart muscle by destroying the toxic chemicals called free radicals that form when blood is cut off during the surgery. Explain why this is an experiment. Well, they're giving them vitamin E. That's a treatment. So that's what I would say. They're giving them a treatment. They're giving the vitamin E. And technically the placebo. I sometimes forget to include that, but they are giving them a fake drug called the placebo. It's probably just a sugar pill. It looks just like the real thing, though, so it's convincing. Identify the explanatory and response variables. I always like to think about X and Y here, and we're predicting Y, we're measuring Y. So it looks like there's two things we're doing here. We're doing vitamin E, and we're doing the placebo, or the explanatory, that's the X or explanatory variables. The response or measured variable, it looks like we're measuring their heart function. Not sure what that means exactly, but measuring that. Identify the type of experimental design in this study. Okay, so let's think about that for a second. So they didn't really group them first. There was no blocking by gender or by age or anything. So it looks like it's just a completely randomized design. I think that's how I'd say it. There's no blocking first, so it's completely randomized. They just put them in two groups randomly and did their stuff. The second sentence above, the phrase, the 14 patients who took vitamin E for 2 weeks before their operation had significantly better heart function after the procedure. What is the statistical meaning of the word significantly in the context of this study? So I think what it's saying is we say it's statistically significant if the results are more extreme than just by chance alone, right? So that's the idea that is that it's more, extreme than chance alone. This was a controlled experiment to describe how it was controlled. So some subjects were given the same amount of vitamin E. Some were given a placebo. They were treated the same way, the groups were, hopefully, so that they could isolate that the treatment was the thing responsible for them getting better. This is actually a problem from even problem from your book. Weekday birthdays. Over the years, the percentage of births that are planned cesarean sections have been rising because doctors can schedule the deliveries. They actually do like that. Doctors love scheduling it. There might be more children born during the week and fewer born during the weekend if births were uniformly means a flat top, like every day of the week equal throughout the week. To investigate, Mrs. McDonald and her class get a simple random sample of 73 people born since 1994, and 24 of them were born on Friday, Saturday, Sunday. Determine if this proves convincing evidence that chance alone. So what I think where they're getting this from, and Brendan helped me see this, that 3 out of 7 days are the weekdays, right? There's 3 days, Friday, Saturday, Sundays are the weekends. Out of 7 are weekdays, so that are weekends. So 43% of the week, approximately 3 out of 7, is weekend days. So that's with nothing going on. That's just, if everything was uniform, you would expect 43% to be in one of those 3 days. But did we get more than that, and how much more? How, what's happening here? So when they do this kind of simulation here, they're basing the simulation off this number. 43% of the time, it's going to be a weekend, right? So they garnered all those numbers by randomly, programming the computer to kind of like randomly spit out that type of random situation. Okay, so we have, and it says the numbers, we don't need percentages here. So 73, where's 73? So, 24 is what I need, 24 out of 73. So 24 is right here. Well, guess what? I mean, I guess we could count it. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 6 out of 73, because whatever that percentage is, 6 out of 73 are at 24 or below. We don't think that's extreme enough to say that the treatment is statistically significant. We think that this variation can be explained by chance alone, or could be explained by chance alone. So is there convincing evidence? Right now, we don't have enough convincing evidence because that falls in the simulation. It's not that unusual, and so we're not going to say it's significant. Okay, we're on to some word problems here. Some more ones. So Mr. Raymond investigated the effectiveness of an online system for learning basic arithmetic skills compared to in-class learning. She will use 30 students from the same elementary school. The effectiveness of the system will be measured by student performance on arithmetic skills test. Describe the design of a completely randomized controlled experiment to test the effectiveness of the online system. Your answers should address all 4 basic principles of experiment design: comparison, blinding, placebo effect, that's together, and random assignment and replication. So I'm thinking a completely randomized experiment. So the first thing you want to do is randomly assign. You randomly assign to groups. So random assignment to groups. There's going to be the treatment group and the placebo group, essentially. I guess, so this is the online system. So we're testing the online system to in-person learning. So one is going to be online and one is going to be in person. Okay, so we randomly assign. That's the important part here that we need to do. Then we control for other variables. We're going to treat as much of this stuff as we can. So maybe the grade level, keep that the same. Duration of how long the instruction is. If it's 53 minutes, make it 53 minutes for both. So controlling as much as we can in this experiment is going to increase the effectiveness of it. We're going to know the result is due to the change in the treatment. At the end, so after we do the treatment, so we give the treatment to them, and then we're going to compare the results, right? So we do compare the results of what happens there. So the different mean test scores for the two groups is what we're going to compare. In replication, so there's 30 students, so we should have 15 in each group. So that's not great replication, but it's some replication. So obviously it'd be better if we had 300 students in the groups. But replication is that you've got enough people to perform the experiment. An exercise science instructor wants to estimate the true mean time the students at his university get up in the morning. The instructor selects the first 50 students to enter the cafeteria in the morning. Why would you choose the first 50? If you're testing how early students get up, you're basically testing the group of students that are up the earliest, essentially, and ask them what time they got up. So this doesn't seem like a good design. The instructor then calculates the mean time for the sample data, identify the type of bias in this survey, and whether or not the sample mean overestimates or underestimates the true mean time. So first thing I know is it's going to underestimate, because we're talking about time. So maybe the real time's 11 o'clock in the morning, college student gets up, but they're bringing that time down. It's going to be an underestimate because they're asking people to get up really early. So whatever number they get is going to be too small, too low there. So it seems like they only, it's not like a very representative group. They get the early risers. What about all those late risers? So if you failed to kind of get a representative group and a whole group of students is just ignored, all the sleeper inners are not part of the study, so it's got to be under coverage bias. So under coverage because they just didn't, none of the late sleepers got in the study. They're only getting the early risers, which is not a great way to go there. So they're not going to get very good results. A lot of bias in that one. Does using a calculator improve understanding of mathematical concepts? 200 fifth graders, I bet you didn't use a calculator much in fifth grade, at Pleasantville Elementary School are randomly assigned to one of two groups. So they are assigned groups, okay? One group studies addition and fractions with the aid of a calculator, the other one, same topic without a calculator. Scores on a fractions test are compared 2 weeks. Now I wonder, do they get to use the calculator or not? Probably not. Is this an experiment, retrospective study, or prospective observational study? So it definitely seems to be an experiment. There was a treatment of types here. So one group got a calculator, one did not. So the calculator, I guess, used with the treatment there. Comment on the extent to which inference can be drawn about the larger population and whether cause and effect can be established. So it does look like they were randomly assigned to the treatment groups, although 200 fifth graders, I don't know how those were chosen. So I think we only have random assignment, which means we can deal with cause and effect. We can say cause and effect is play, but we cannot make inference to the population here. Okay. 14, a large company has 4 major divisions. A human resources manager wants to select a sample of 40 employees to assess employees' feelings regarding working conditions. Because of the differences in leadership and stress levels among the 4 divisions, the manager feels the divisions in which each employee works is a major factor in assessing feelings and working conditions. So describe a sampling method that takes into account. Now, key word here is sampling method. We're not doing an experiment. Sampling method. So we want to stratify, right? We're going to stratify a stratified random sample, and we're going to do that within the 4 divisions there. So we're grouping similar folks together. So each group of division, division seems to be similar, within themselves, but different. For the 4 divisions are quite a bit different, evidently, different levels of stress and so forth. So we're going to. So, I mean, because these 4 groups are just within each group, there's similarities. They're homogeneous groups, but each group is different from each other. So if you take a random sample in each group, you sample randomly, random sample within each group about the same number of folks, then you're going to get a nice hodgepodge of everything. It's going to be a representative group. If there's really is what they described there, that's a great way to go. They're similar within the group, but give more precise estimates than just a simple random sample would. So it'll be better than that at least. Farmer, this is many, grows and sells 2 popular varieties of tomatoes, Better Boy tomatoes and Big Beef tomatoes. Both varieties of tomato take about 75 days to mature. She's designing a study to test the effectiveness of the new soil additive to increase tomato growth. She has 40 Better Boy tomatoes and 60 Big Beef tomatoes for her experiment. Preliminary research suggests that Better Boy tomatoes and Big Beef tomatoes respond differently to the additive. What sort of experimental design would you choose for this study and why? So now we're designing an experiment, right? In this case, because we are imposing a treatment here. So designing experiment, we want to do, you're going to block. So I would call it randomized block is what you're going to do. You're going to block by variety, right? There's 2 different types. You got the Better Boy and the Big Beef tomatoes. So you're going to block that first, put those in similar homogeneous groups. And then within each group, you're going to do a completely randomized design inside of there. That's how randomized block works. Explain why an experiment involving 40 Better Boy tomatoes and 60 Big Beef tomatoes is preferable to one involving 4 and 6. Well, the larger the sample size, the more precise the predictions are. So that's basically it. Describe a design for this experiment. Be sure to include a description of how you assign individuals, treatments, and groups. Okay, so we're going to do that completely, that block, randomized block. So you're going to block. So we block not by randomness. We choose one group, 40, Better Boy tomatoes. And there are 60 Big Beef tomatoes. Wow, my abbreviations do not work out very well there because Better Boy is the same abbreviations as Big Beef, but hopefully this is the beef one and this is the boy one there. Okay, so we are not randomly assigned. So now within each block, we do random assignment. So we randomly assign the treatment or the, placebo, if there's a placebo here. And by the way, this would be 20 and 20, right? Or what you're going to choose. This one's going to be 30 and 30. We're going to choose half in each. It's a fair way to do it. And so you have to describe a method of doing that. Some of you might use a random number table and take 2 digits at a time, going left to right, ignoring repeats. You might have to specify that the Better Boy tomatoes are the numbers 1 through 40. And the Big Beef tomatoes are the numbers 41 through 00. I'm saying that because that's like 100 there. It'd be 399 plus 1 more, which is 00. This is why I think of it. And so you're going to assign numbers and get, pick 20 for the group that gets the fertilizer. And then the other group, it's not really placebo, it just doesn't get a fertilizer. It's still a treatment or lack of treatment essentially there, but we call it the placebo treatment if it's treatment. So you're going to study the results, and hopefully that the groups, these compare the groups, right? At the end, you're going to compare the groups after 75 days. And did the group that got the fertilizer do better or not? Okay, that's the results. Excellent. Okay, that's the end of your screencast.